Hi, I welcome you all another presentation on control system subject. We are discussing various specifications, time domain specifications of a second order control system. If you recall our previous presentations, there we have seen basically there are five types of important specifications we have seen. Okay, if you refer our previous presentations, there you can see various time domain specifications. What are those? One is the delay time, second is the rise time, third is the peak time, and fourth is the maximum peak overshoot, and then the fifth one is the settling time. These are the very important time domain specifications, and you can expect questions either in GATE as well as in UPSC's IES examinations from these parameters, definitely. So by the way, today I am going to explain you one more important question that is asked in UPSC's IES examination in the year 2006. So, we'll see the problem. By the way, today we'll see in our lecture number is 39. In this presentation, I will explain you one important question that is asked in UPSC's Union Public Service Commission IES, that is Indian Engineering Service Examination 2006. So in ECE branch, for ECE students, for ECE discipline, they have asked in 2006, they have asked. What is the question? What is the question? The question is find the value of gain K. The question is find the value of gain K for the feedback control system, for the feedback control system shown below. Shown below such that what is that? The system will be under damped such that the system means the control system, such that the system will be under damped the system will be under damped and will respond with 16% peak overshoot. Peak overshoot. This is the given, and there is a block diagram. I will write that. This is the question normally. Find the value of gain K. Okay, find the value of gain K for the feedback control system. What is the feedback system? I will draw here for your this thing. This is the system given actually. This is g of s given like this only. G of s is equal to, it is k by s into s plus phi. This is the g of s value. K by s into s plus phi is nothing but your g of s. This is c of s. This is r of s, and it is given like this with negative feedback. Means that here just they have given one line only in feedback, just it is given like this. That's all. This is the given block diagram. This is what feedback control system. So you are asking that find the value of k, or r of s is obviously plus. Actually this is minus, means the output. C of s is our output, r of s is our input. So part of the output has given feedback with negative feedback. So it is going to minus sign, then it is called negative feedback. If it is plus, then it is positive feedback. So it is a negative feedback control system. Okay, so here you are asking that find out the value of k. So here, as the output, part of the output is given like this, it means that what? Normally we know that this is a g of s. Basically g of s is the gain of the amplifier, let us call. And here also we have another block. No, what is the gain of that block? H of s in general. But whenever the line will be given like this, assume that your H of s value is 1. Consider that your H of value is 1. Means that what? This is a unity feedback control system. This is called the unity feedback control system. Unity feedback is nothing but the feedback value becomes, the gain of the feedback is 1. That is the meaning of it. Therefore, whenever this type of problem will be given, so you can find out C of s by R of s. C of s by R of s directly from the characteristic equation. You can write the characteristic equation. What is the characteristic equation? I will tell you. Or otherwise, you can simply by knowing our initial, presentations, if you see C of s by R of s for the negative feedback control system, what is the formula? That also I will explain. Before that, let me complete the problem. Actually, this is the given problem. So he is asking to find out gain k value, and it is responding for 16% of peak overshoot. Then what? He is asking some parameters to find out in this problem. What are those parameters? I will write. Problem is not yet completed. Only I have explained you the half of the problem only. And now with this diagram, he is asking, in the problem, they are asking us to find out the parameter. Then find out the following, he is asking. Find out the following. Find out the following. The first one. What is, for undamped natural frequency? What is undamped natural frequency? This is nothing but your omega suffix n. That is first parameter he is asking to find out. The second one, damping ratio. Damping ratio, are also called as damping factor. What? Damping factor. Normally it is nothing but your zeta. Damping ratio, or otherwise can also be called as damping factor. Both are same, can be represented with zeta. What is the third parameter they are asking, that is the peak time. Peak time. Peak time, that is T suffix P. Sometimes in the examination they will ask you like this. What is that? Time required to reach the first maximum. Time required to reach the first maximum, nothing but your peak time only. First maximum, to reach the first maximum, nothing but your so they are asking to find out the peak value. That's why directly I am writing here peak time. Okay. Similarly, what is the fourth parameter? That is the time required for the transient to respond to reach within the 2% of the steady state value, nothing but settling time. It is settling time. Normally, if you write all that sentence, the space will not be, sufficient. That's why that is nothing but settling time he is asking. And the fifth one is the damped natural frequency. Damped natural frequency. Natural. Damped natural frequency. What is damped means? Omega suffix t. So these are the parameters. What is that? Undamped natural frequency, omega suffix n. Damping ratio or damping factor, nothing but zeta. Peak time, Tp. Settling time, Ts. Damped natural frequency, omega. All these are known from our definition of standard form of transfer function. We have seen the formulas for all these things. Clear? These are the factors we need to find out for the given problem. Now, in order to find out these parameters, what we should do is that, first of all, for the given block diagram, you need to find out the transfer function. What is the transfer function? I will erase this just for your understanding. I will draw the figure again. This is your C of S. This is your R of S. It is K by S into S plus 5 basically, and it is given with negative feedback. They are giving, you can write like this also, nothing wrong in that, but H of S you can write as 1. Clear? So this was the given basically. From this block diagram, you can write, this is the unity feedback, or otherwise, even though if they give some value of H of S, you directly remember one important formula is that the characteristic equation. Remember that the characteristic equation can be written first. The characteristic equation. What is the characteristic equation? Characteristic equation is nothing but 1 plus G of S into H of S equal to 0. This equation is called as characteristic equation. 1 plus G of S into H of S equal to 0. That is what characteristic equation. Or otherwise, as it is a negative feedback control system, if you write the ratio C of S by R of S, if you write the transfer function, that is C of S by R of S, normally this is equal to, for a negative feedback, what is the general formula? What do you know? G of S by 1 plus G of S into H of S, is it not? For negative feedback control system, this is the definition. We already know this. For a negative feedback control system, C of S by R of S, output by input, is nothing but C of S is your output, R of S is your input, output by input, nothing but your transfer function. This is called transfer function. That is what G of S by 1 plus G of S into H of S. So this is the numerator, this is the denominator. If you equate the denominator part equal to 0 like this, this is what your denominator, no? 1 plus G of S into H of S, the same 1 plus G of S into H. So you equate to 0. That's what I have done here. The same I have done here. If you equate this denominator part, then this particular equation, now it is a equation. This is called the characteristic equation. Therefore, so what you know? G of S you know, H of S value is 1. Substitute that G of S value in this equation. What you will get? Then I will erase this diagram. This implies basically 1 plus g of s into h of s equal to 0. This is what your characteristic equation. Clear? Then what we should do here? This implies further 1 plus, what is your g of s? It is k by s into s plus 5. Clear? What is h of s value is 1 because unity feedback. This is equal to 0. Furtherly, this implies take cross multiplication here. S into s plus 5 multiplied with 1. Therefore, s into s plus 5 will come. Clear? Plus k into 1. It is k equal to 0. And further, if you expand this s into s, it is s square. S into 5, it is 5s plus k. This is your characteristic equation. This is a characteristic equation. Clear? Now, see that it is a second order equation. S square means the highest power of this equation. The highest power of s is 2. That's why it is called a second order equation. Now we should equate this equation with the known or with the standard form of our transfer function. Okay, so what is the standard form of our transfer function, or what is the standard form of the transfer function? We know that the standard form of transfer function is equal to T of f, transfer function, nothing but your C of s by R of s. Clear? This further equal to, what is the formula? It is omega n square by, it is s square plus 2 times zeta omega n into s plus omega n square. This is what the standard form of the transfer function of a second order system. Now, what we should do here? You compare this equation with this denominator part. Consider the denominator part of the standard form of the transfer function. This is the standard form of the transfer function, omega n square by s square plus 2 zeta omega n into s plus omega n square. So, in the denominator part, this is the equation we have. This equation must be equated with this. Clear? Let us call it as equation number 1, let us say, for our reference. Let us call this as equation number 2. Now equate 1 and 2. Then by equating the s square coefficients, s coefficients and constant, you will have some values. So if you compare equation 1 and 2, compare equation 1 and equation 2. Compare these two. Then so s square, you have s square here, you also have in the second, the first term as s square. Clear? Now what is the s coefficient here? The s coefficient is 5. Then in the standard form, what is the s coefficient? 2 zeta omega n. Therefore your 2 zeta omega n is equal to 5, both s coefficients. So if you equate, clear, then your k is equal to omega n square. So you must write that k is equal to omega n square. That is one relation. Again, it is 5 is equal to 2 zeta omega n. So write that. You write those two equations, those two relations. So the first one is what is that? 2 zeta omega n. From here 2 zeta omega n is equal to what? 5. Clear? From this you can write some zeta value, no? Zeta value is equal to how much? It is 5 by 2 times omega n. Clear? From this zeta is equal to 2 into omega n. This much 2 into omega n will be goes to the right side and comes in denominator part. Therefore zeta is equal to 5 by omega n. This is one relation we obtained by comparing these two. And what is the second? K is equal to constant. K is equal to omega n square. Clear? K is equal to omega n square. Write that. So similarly, your k, or otherwise write like this also, omega n square is equal to k, is it not? There omega n square, here it is k. This implies what you will get? This implies omega n is equal to root k. This is another relation. These are the two relations we obtained by equating these equations. Now what is given? What is given? There is one condition is given, because so for the system is responded, or the system is responding as under damped for what value of peak overshoot? It is 16% of peak overshoot. Clear? For the 16% of peak overshoot. Okay, so then we know that the peak overshoot is given for this. What is the peak overshoot? What is the formula? So it is the percentage of peak overshoot MP is equal to e power minus zeta pi by square root of 1 minus zeta square. This is the formula for your peak overshoot, and this much is equal to given 16%. Means that what? This implies percentage of MP value is given, that is 16% actually. That means what? That means e power minus zeta pi by square root of 1 minus zeta square is equal to 16%. Means 16 by 100. This is equal to further 0.16. Clear? 0.16. Now you take both sides natural logarithm by taking, write that, by taking natural logarithm log on both sides. On both sides you write. Then what you will write? ln, natural logarithm is ln of e power minus zeta pi by square root of 1 minus zeta square is equal to ln of 0.16. Clear? This is what? Okay, so here then this ln natural logarithm and then exponential both will be cancelled out. Then what remains here? E power that I will write in this expression. Because it is a conventional paper, that's why you need to give the step-by-step answers. Then only in a UPSC's examination, for each step there is a weightage of marks. Okay, because the presentation of answer gives a good appearance, thereby each step is very valuable. How you are reaching to the final value is very important, and your steps should be very clear cut. How you are presenting the answer is very, very important. So it is not like that as your university examinations. In university examination, you can write something and you can write whatever the way you represent, or sometimes you can write in different ways of your handwriting. Your handwriting is also very important. That's why follow it how I am presenting. Look at my presentation. I think it is okay. So I expect you all, you must present very best manner than me also. Okay, so very clearly we should mention step by step. Each step is evaluated. Your each step is that is weighted. Means it is considered into account for awarding the marks. Okay, that is why. So you have to give very, very clear cut way of presenting your answers. Therefore now, so this natural logarithm, this will be cancelled out. Then what will remain here? E power minus zeta, e will be cancelled out, no? Minus zeta pi by square root of 1 minus zeta square will be there. This is equal to natural logarithm of 0.16. If you calculate that from your scientific calculator, it gives, you will reach the value minus some 1.832 like that normally. This I have calculated from scientific calculator. Then so you will get this. Clear? So natural logarithm of this value, you just apply ln of 0.16 from your calculator, you will get this value. Then both sides the minus sign will be cancelled out. Then what you will have? It is zeta pi by square root of 1 minus zeta square, and then it is 1.832. Okay, take then for this cross multiplication. Take cross multiplication here. Then what you will get? It is square root of 1 minus zeta square of means total into 1.832 is equal to zeta into pi. This implies as we have root square in one side of this equivalent, that's why what we should do, you have to remove this square. Then what we have to do, on both sides square on both sides. By squaring on both sides, by squaring on both sides, what you will get? What you will get? Square on both sides. Then what you will get? So you will get like this. You will get like this. I will write here. Means, so the root will be out here. Means you will get 1 minus zeta square into 1.832. You will get square for this. This implies zeta pi whole square. Is it not? Nothing but your zeta square and then pi square. This implies from this, what I mean to say is that you find out the zeta value, or otherwise, okay, or otherwise what you will do? So you can take zeta square as a common. So zeta square pi square can be taken common. Therefore, or otherwise what you will get? 1 minus 832 square. Just with this square I am multiplying inside. So 1.832 square into 1.832 square minus this square into zeta square means 1.832 square into zeta square is equal to zeta square pi square. Clear? So from this, so zeta can be calculated, no? From this, either this part you take out right side, then you take zeta square as common, then it comes pi square. If you take common zeta square as common, pi square, take this minus to the right side, then plus it comes 1.32 square basically is equal to what you will get? 1.832 square basically. From this, what is zeta square? Zeta square is equal to 1.832 square by this entire thing, pi square plus 1.832 square. From your calculator, take pi as 3.14. You know, no? 3.14. Substitute 3.14 here. Then take 1.32 whole square value and again 3.14 square into 1.832 square. So if you take this calculation, so zeta square value you will get something. Zeta square value you will get something as 0.254. You will get 0.254. That is what your zeta square value. And I want zeta. So zeta is equal to square root of this. Clear? So what you obtain, zeta square is equal to 0.254. Then zeta is equal to square root of 0.254. It is nothing but 0.5. It is nothing but 0.5. You can say 0.5. Therefore, you obtain zeta value is 0.5. Therefore, what you got actually? What you got? Therefore, now coming to the questions, what they have asked basically, undamped natural frequency, and undamped. What is the first one? Is undamped. Undamped natural frequency, nothing but your omega n. What is omega n? We have seen, no? So that is omega n square is equal to k, or omega n is equal to root k. This is the relation we must remember. So keep like that. Now say for example you have obtained one relation for zeta. So what you obtained for zeta? Zeta is equal to previously just in previous step, so in our previous step we have seen that zeta is equal to what we have seen? 5 by 2. What we have seen? 5 by 2 times omega n we have seen, no? 5 by 2 times omega n. Omega n is equal to root k. This is equal to 5 by 2 times root k. This is what? Zeta. So, but zeta we have obtained. This is what damping factor. This is the, I think which one? Fourth one, no? Damping factor they have asked, no? Damping factor, second one. If you see the questions, the 1, 2, 3, 4, 5, the second point is damping ratio. This is the damping ratio. Now substitute your damping ratio value here, 0.5, and this implies if you put 0.5 here, this is equal to 5 by 2 times root k, and from this you solve for k. K is equal to how much you will get? What you will get? So your k value comes 5 square. You will get 25. Simplify this. You simplify this. Just you bring this root to k here, then 0.5 here, then k is equal to, you have to square on both sides, na? Normally this point, okay. So 0.5 into 2 is 1. 0.5 into 2 is 1. Therefore 5 by 1. Root k is equal to 5 basically. So k is equal to 5 square, 25. So k is equal to 25. So this is what the question they have asked. Find out the value of the gain k. So this is the value of gain k. Gain constant. This is called gain constant. So k value is 25. That is one thing they have asked. Damping factor, however, it has come. And similarly, so this is what, so you obtained k value, no? K value is 25. Then what is omega n? This is the undamped natural frequency. From here, what you can write? Omega n square is equal to, or root k. What is k value? K value is 25. Means your omega n is equal to root k, root 25, nothing but 5, na? Radians per second. Radians per second. Remember that omega n natural frequency, undamped natural frequency or damped natural frequency is measured in terms of radians per second. It is 5. Therefore, your answer is 5 for undamped natural frequency. Then what they have asked? So undamped natural frequency has come. The damping factor, this is the second parameter they have asked. That is also find out. Time required to reach the first maximum means peak time. What is the peak time? What is the peak time? What is the formula for peak time? TP. TP is equal to pi by omega d. So, okay, na? Peak time. The third one, whatever they have asked is peak time. Peak time. Nothing but TP. The formula is pi by omega times d. This is equal to pi. What is omega d? It is for omega n into 1 minus zeta square. That is the formula. This is the damped frequency, damped natural frequency, and the relation between damped and natural is this one. Omega d can also be written as this one. Now you know everything. Pi, wherever pi is there, you substitute 3.14. Omega n how much? Omega n is how much? How much you got for omega n? It is root 5, na? Omega n is equal to, okay, omega n is equal to 5. Okay. omega n is equal to 5, means 5 into square root of 1 minus what is zeta value? Zeta value is 0.5 square. So simplify this. Then pi by omega d, your peak time will comes that 0.72 seconds. This is simple calculation only. 0.72 seconds. Simply formula, you have to remember the formula pi by omega d, substituting that. That's all known parameters only. That is the peak time. Then what they have asked, then settling time. Next is the settling time with 2%. So next formula is settling time for 2% of tolerance band. The fourth one is settling time. Settling time. What is that? T suffix s for 2%. For 2% of band, tolerance band. For 2% of tolerance band. What is the formula? Ts for 2% is equal to 4 by zeta times omega n. This is 4 by, what is zeta? 0.5 into 5 radians per second. So simplify that, you will get Ts value as 1.6 seconds. You will get 1.6 seconds. 1.6 seconds. That is the thing. These are the formulas. 4 by zeta omega n is the formula. You substitute all known values here, then you will get this one, 1.6 seconds. Okay, and the lastly, damped natural frequency. Damped natural frequency. Damped means omega suffix d. Remember, damped natural frequency. Damped natural frequency. Nothing but omega suffix d. Now, what is omega suffix d? That is nothing but omega d is equal to omega n into square root of 1 minus zeta square. This is what? Radians per second. Radians per second. This implies omega n already we have calculated 5 and the square root of 1 minus zeta is 0.5 square. Then omega d already we have obtained that. Omega d value is comes, if you simplify this, it is 4.3 into 3 radians per second. So it is simple calculation actually. All are very, very simple calculations. This is the formula you need to remember. The main objective of this is that just I want to present you the formulas. If you know the formula well, all parameters to be substituted in that formula and you will get the respective answer. Clear? So I think you have enjoyed this problem, and with this I finish off this particular presentation. In the next subsequent presentation, we will see some more examples on this time domain specifications, right? So thank you one and all.